In this video, we're going to use the Pythagorean Theorem formula to find the distance between 2 points, and we're also going to apply the distance formula. Let's start with the Pythagorean Theorem method. So to do that, we need to graph -2, 5, and 3, -1. What you're going to do is you're going to draw a 90-degree triangle so that you can find the distance between these 2 points that I just drew in blue. Some students tell me that they have trouble figuring out how to draw the triangle. They just can't picture it. So here's one method that could work for you. Find the 2 grid lines that cross through your point and just continue those grid lines. So draw in those grid lines. Do the same thing with the other point. So there's 2 grid lines that go through the other point as well, and you'll see a rectangle and inside 2 triangles. The green one that I just colored in, and then the one that we drew originally that I just put a 90-degree angle inside of. I know that that's a 90-degree angle here in the corner because these are all squares on this grid, and every square has 4 90-degree angles. So in this corner, there is a 90-degree angle. Across from the 90-degree angle is C. So we don't know C. C is the piece that we're always trying to find in a problem like this. It's the diagonal. We do know A and B. We can count the lengths. So I'll label this B, I'll label this A. A is 1, 2, 3, 4, 5 units long, and B is 1, 2, 3, 4, 5, 6 units long. So all I do is I fill in 5 for A, 6 for B. I square 5 and I get 25. I square 6 and I get 36. Add those two together, you get 61. Take the square root of each side, and I'm going to go ahead and use a calculator. The square root of 61, we get 7.8 when we round, so I'll make that approximate. So I rounded to the nearest tenth. So this length, the distance between these 2 points, is a length of 7.8 units. Now what we're going to use is a different method, the distance formula method. But we should get the same answer. The point of using the distance formula is that you might have some really large values. For example, what if you had the points 100, -1000, and -700, 1 billion? You're not going to want to use the Pythagorean theorem and draw out the picture. You're going to want to use the distance formula, which was derived from the Pythagorean theorem. I'm going to label my 2 points. So I have -2, 5, and I have 3, -1. So I'm going to label this x1. Oops. Let's see if this will come back. I couldn't get it to come back, so I just rewrote it so it might look different, and I added a little bit. So now we're going to go ahead and fill in our information. So I'm going to take x2, which is 3. I'm going to take x1, which is -2. And then I'm going to plug in the y values. So I have y2, which is -1, and I have y1, which is 5. And then we simplify. So -1 minus 5 is -6. And 3 minus a -2 is 5. So we get 25 plus 36, which you probably recognize this, and we'll get to the same 7.8, approximately 7.8. The other thing I want to mention is that it's not going to matter if you mix up these two. You could write x1 minus x2 and y1 minus y2. In fact, you could have y1 minus y2 and then x2 minus x1. You could have them opposite. It won't matter because when you square it, whether the result is negative or positive won't matter. You'll still get the 25 and 36 at the end. Let me show you really quick that we'll get the same thing. I'm going to change this to x1 minus x2, and this to y1 minus y2. And I'll do this in green. So we have x1 was -2, x2 was 3, and y1 was 5, y2 was -1. 5 minus -1 is actually +6, and -2 minus 3 is -5. But no matter if you have -5 squared or 5 squared, you still get 25. It doesn't matter if you have 6 squared or -6 squared, you'll still get 36. So it does not matter. And I'll do another example in the next video.